Okay, so the cells that make up bone tissue are what we consider osteoblasts, osteocytes, osteoclasts, and osteoprogenitor cells. Okay, so what we've been talking about in extent up to this point was the osteoblast. We already went through the fact that he is the one. That's the one that's related to making most of the bone tissue. The young immature cell has a lot of activity and energy. So he's going to be one making bone tissue, what we've been talking about. Once he gets trapped, he then turns into the osteocyte in the lacunae. And so basically what we consider a bone cell, that's what that is, osteocytes, just a bone cell, you know. But they were osteoblasts before that, okay? And where osteoblasts came from were their parents, which are osteoprogenitor cells, okay? Even in English diction, we have progenitor means your ancestors, right? So those are the cells that are those are your main bone cells, and also your osteoclast. He's a bone cell as well, except he comes from a different lineage. Even though your what? Osteoblasts that eventually turn into osteocytes came from an osteoprogenitor cell. Its true lineage is bone cells. Osteoclasts come from white blood cells. Okay. So our understanding of what an osteoclast is something we talked about already with relationship to the Langerhans cell in the skin. This white blood cell that constantly eats. Okay, and yes, he'll be what you consider a phagocyte, a cell that eats consistently, but he's going to eat up bone material, right? So this is an interesting cell here. Even though he's a bone cell, he doesn't come from the bone. He actually comes from the actual blood. He comes from white blood cells. It's very interesting there. And so that's why he's actually always going to go against whatever osteoblasts and osteocytes do. It's a consistent, if you will, all the time battle between your osteoblasts and osteocytes against what? Osteoclasts. Obviously, the main cell involved with making bone tissue, though, is your what? Osteoblast. So that's who the osteoclasts are always going against. It's always this osteoblast versus osteoclast story, okay? Which is great because it balances things out. And as these guys consistently go against each other, okay, that is going to balance things. That's what we consider bone remodeling, okay? Bone remodeling is a great way in refurbishing, if you will, your bone. Always having new material in bone as it relates to this battle between the two, all right? And so that's what we call bone remodeling, all right? It's great. It keeps bone new. It keeps bone new that you have, all right? And so basically, yes, now you can see their functions, how important they are, and what they do. You can apply to other things as well, like let's say you get a fracture, right? If you need more bone material made, who's going to do that? Osteoblast, right? So not your osteocyte, right? If you have a bone fracture, who do you want to come in and save the day? The one that mostly makes bone tissue, not the one that just maintains it, right? Okay, the adult doesn't have as much energy as the what? Blast, the actual immature cell. So you're going to have, when you have some sort of damage done to bone, obviously your main cell that's going to make that material up is your osteoblast. Okay, so this is great. It gives you a good idea of what's going on with the material that's made and who's involved. These are all the cells involved. This is what we call our bone cells. Osteoprogenitor cells, your osteoblast, your osteocyte, osteoclast. Okay? Very good. All right, so now when we go to what we consider your bone formation and bone developing process, bone formation actually begins, okay, with two different types of processes. Okay, and that's what we're talking about here is bone formation or bone growth. Right. So those two processes are called, if you will, intramembranous ossification and endochondral ossification. Right. So what we have is intramembranous ossification and your endochondral endochondral ossification. Ossification means bone growth, bone development. So there are two different ways bones can grow, okay? And they both begin at the same time, at around 8th to 12th week of gestation. When you were in your mother's womb, in her uterus, when you were a fetus, when you were actually, before you came out of the uterus, right, that's called a gestation period. And early on there, 8th to 12th week, this is when these two bone development processes began. At the same time, between that range between 8 to 12 week. But when we're talking about intramembranous, we're talking about more so the bones that develop were the axial skeleton bones. A lot of those. And a great example of one of those is the flat bones. So flat bones and how they develop is a good example of this intramembranous ossification versus endochondral ossification. A great example is your long bones. Okay. So when we're looking at the two different types, all of the bones in your skeleton, different types of bones. Don't forget your 4 different types, right? Your long bone, that's the only one that has an actual cavity in it, a cavity, and it's called a medullary cavity. Then you also have what we call short bones, just like the actual, so long bones are like your appendicular skeleton. Most of those appendicular skeleton bones are long bones. Your humerus, your femur, and what have you. But your actual short bones, that's like the pebbles on the beach there, like your wrist bones, carpals, and your tarsals. And then we have irregularly shaped bones, the ones like we have your sphenoid and ethmoid, Then you have what we consider your flat bones. Flat bones that, for instance, like your actual parietal bone, and very flat looking. Obviously, they're going to be great with protecting. A lot of times protected. Very good. All right, so different types of bones, that means they grow in different ways. And the intramembranous ossification way, okay, is when you first start with an ossification center. And simply what an ossification center is what we just saw, which is your osteoprogenitor cells,